In this tutorial, we're going to perform a static analysis of an assembly. In this lesson, you will learn applying fixture restraints and directional forces. You will also learn suppression and assembly components for analysis, listing reaction forces, customizing the color map of the plot, generating and modifying a section plot, and a proper result on the section plot. Here's the result. You can see the pulley is fixed. Force have been applied on this crank, and the deformation is shown after the force being applied. We're going to start with a new assembly. To do this tutorial, first you need to download 3 components from a weekly tutorial folder: a crank arm, crank axle, and a crank pulley. Once you download it, we can start create a new assembly. The first one would be the pulley. Let's put it here and save the file before you do anything else. Say tutorial, take analysis of an assembly with your initial. Okay, then we would like to put my pulley in correct location, make it flow, and then use mate. You can see here I would like to make a front plane aligned with coincident with plan 1. Okay, top plane aligned with plan 2, and the right plane with plan 3. Okay, so my first component, pulley, is incorrect position now, and you can use Control 7 to bring it to isometric view. Save your file. Now we are ready to insert the other component. We're going to make the shaft mate. So use this cylindric surface and this hole concentric. Okay, and then we would like to make them in the middle. So what I can do here, we can use advanced mating, and we're going to use width. So we're going to make this face and this face, and then use this face and this face. You can see it is being centered. It's okay. Save my file. Now we're ready to insert the pedal or the crank. Here. So we are going to use mate to put in correct position. First, I would like to use this cylinder hole, and here make it concentric, and then I would like to use this face coincident with this step face. Hit OK. Control 7. I would like to make it down here. So what we can do here, we can use concentric or use parallel. And I would like to use right plane and make my crank parallel to plane 3. Okay. Now you can see is completely constrained. Control 7. Okay, I'm satisfied with my results. Then I can save my file. Now we're ready to make the other crank, or to insert the other crank arm. We can use control click and drag it to get my second component being copied. You can see here we have crank 1 and we have another crank. Now let's save the part, rebuild and save it. Now let's put this one to here. It's free to move. We can use mate. This one, let's say this one aligns with this step, and let's change its direction. So my pedal is facing in other direction. And now I would like to use this one, the cylindrical face, concentric with my shaft. Hit OK. But still be able to rotate, right? So we would like to make a parallel. Then it's right plane with the plane 3. OK. Hit OK. Now my assembly is being completed and in the correct position. I can save my file. In the meantime, you can see we have a whole bunch of mates being put here. We can suppress it instead of using it to avoid cause additional problem in simulation. Now we're ready to start our simulation. Go to simulation and click new study. Make sure we select static. Give the name static assembly. Hit OK. You can see here we have 3 parts, right? Crank arms 1 and 3, 2 arms, and axle and crank pulley. Now you can see we get a global contact and bonded incompatible mesh, right? So this is automatically generated as long as you put this assembly in your analysis. This is automatically used. Now let's create a fixture. The fixture geometry, we use the out surface of this pulley. Hit OK. Now you can see the pulley is being fixed. And let's say we're going to apply force on it. Apply force. This time we would like to use selected direction. We also would like to use IPS. The surface reference plane we would like to use is, say, in this case we would like to use the front plane in this direction. Okay, and then you can see the force along plane, front plane, and let's say we use the. We can also use the pulley. Which in this case will be plane 1. Okay, so then along direction 1, you can see the force we would like to apply will be on this cylindric face. Once we select this one, then you can see it is being shown. Right? We would like to put 200 pound force here, and we want to reverse direction. You can see the direction is pointing to positive x direction. We would like to reverse it, then it pointing to negative x direction. Hit OK. And you can see a force is being displayed in this tree. Let's save the file. Now let's create a mesh and run the simulation. Create mesh, run solver, analysis. We just use the default at this simulation. Okay, here's my results. Put it here. Okay, then we can look at our results, right? So here's the displacement, here's the stress, and here's the strain. Here's the displacement, right? The largest displacement is at this tip. All right, so we will look at this result and do some modifications. First, let's hide all my fixture and all my forces. Hide all. You can see we only displayed the component, the assembly, without the fixture and the load. Alright, so next step, we're going to double click stress, and we would like to change the unit to PSI. Hit OK. Look at here, it's a Newton per meter square, right? That's Pascal. So that's by default. Let's put it here and save my file. Then you can see the value distributed here. What we have is the whole assembly, right? If we look at here, you can see we have the pulley, and the pulley does not show any strains, show any displacement, no strains. Very small strains, right? So, and if we only interested in the crank itself, what we can do here, we can probably simplify this study. What we can do here to exclude this pulley in our study. Okay, let's use this one to show model only without the results. Then we're going to exclude, right click our pulley, and here says exclude from analysis. Once you click it, you can see we only see 3 components here, and also you can see the fixed one is being suppressed because your component related to this fixture is also suppressed. And you can see because the mesh, because component is updated, so your mesh is out of data. Result is out of data as well. There's one more thing before we can go to next step. We go to the Feature Navigator, and then we make the pulley hidden, and then we save the file. Now we can see we still have the force. Let's show it. Force is here. We need a new fixture. What we can do here, we can make this center cylinder to be my fixture, and then save my file. Then we'll get all the information being updated. Then let's create mesh and make sure run solve the analysis. Use the default. This time you can see my mesh is a little bit different from the previous one. Let's hit OK. And now my analysis is being updated. Let's look at, save my analysis first, and then look at my results. Right click. You can see we would like to create a new stress. Right click. Right click. And let's see animation. Right, here's, you can see the stress being applied here. Right. Okay, we can also look at the results of displacement. You can run animate. Okay. If you want to see the strain, you can also right click and show it. Alright, let's look at the stress at this moment, and then we can see the van mass stress is being displayed in the analysis model. Control 7 to bring it to this analysis. So what we can do here, we'll look at the reaction force. So right click, results, and let's look at released result force, and we would like to see its location will be here, and use PSI. You can see reaction force been displayed here is here, right? So we can update. Heat reaction force. Heat. Okay. For the plot, we can also select the chart property option, and you can see here color option. By default is a rainbow. We can use user defined. Here is a 10. We want to change this to 3, and also change this to 3. And we can double click this green one, make the red. Hit OK. This one is magenta. Should be OK. And then we make this one be blue. If you want to make another color as your color option, then you can also do that. Hit OK. Right, now you can see it's displayed in a different way. We can also create a section. What we can do here, select define, use the define stress plot. Define stress plot. Okay, so we use PSI, and we use make sure we use one mass stress in the components, and the PSI. Hit OK. Now we have stress 2, right? So right click stress 2. We have section clipping. What we are going to choose for this plane, we would like to choose right plane, and here we would like to say uncheck this one. We don't want to see the section plane, and hit OK. Now you can see it has been sectioned, and the result is being displayed with my section. Save my file, bring it to isometric view. Right. We can also display the model with my deformed result. Go to settings. This time go to setting, right, and then deformed plot. We superimpose, and you can see translucency. Just use a single color. Hit OK. You can see the model, translucent model, is being shown here. If you think it's not clear, we can make this translucency value smaller, say 70, 75, something like that. Hit OK. Now it's more clear. Let's save the file. Control 7 to bring it to the isometric view. Let's hide the stress and hide my forces as well. Now we can also use this prop to see the stress as a location I'm interested in. For example, this one, this one, this one, this one, and this one. You can see the location 1, 2, 3, 4 being displayed here, and what you can do here, you can also plot, right? The stress decreases from 0.0 to 0.4. You can also save your results, okay, and then close it, hit OK, and then save it. That's for the tutorial.